Good morning all. How are you? I hope you all are fine. Okay students, in our last class we study physical properties of metal and non-metal. Okay, what we study? Hardness of metal and non-metal, physical state of metal and non-metal, malleability of metal and non-metal, appearance of metal and non-metal. Is it? Yes, today we are going to see the next physical properties of metal and non-metal. See, physical properties of metal and non-metal. The next one is ductility of metals, ductility of non-metals. Ductility of metal means most of the metals can be drawn into thin wire. Okay, most of the metals can be drawn or structured into thin wire. That means the most of the metal can be made into thin wire. That property is called ductility. Okay, for example, if you consider an electric wire, it is made up of copper or aluminium. Okay, I will show. See, this is an electric wire. It is made up of copper. See, we can see copper wire. Okay, the metal copper drawn into thin wire. The metal copper drawn into copper wire. Okay, the next is, this is an electric wire. It is made up of aluminium. See, this is aluminium wire. Okay, the metal aluminium can be drawn into thin aluminium wires. Okay, if you see in the case of bulb, okay, inside the bulb we can see thin wire. Inside the bulb we can see thin wire. Okay, that is filament. This filament is made up of tungsten. This filament is made up of tungsten. So tungsten is a metal. Okay, so most of the metals can drawn into thin wire. That property is called ductility. That property is called ductility. Okay, the property of a metal by which it can be drawn into thin wire is called ductility. Is called ductility. Copper wires, aluminium wire, tungsten filament. Okay students, the most ductile metal is platinum. Platinum is the most ductile metal and gold is the most malleable metal. Okay, platinum is the most ductile metal, gold is the most malleable metal. Okay, the next one is ductility of non-metals. Here, the most of the non-metals are not ductile. Okay, for example, carbon. We cannot draw carbon into thin wire. If you try to draw this carbon, it will break. So, most of the non-metals are not ductile. See, most of the non-metal are not ductile. Example, carbon, sulfur, etc. Okay. The next property is sonority of metals, sonority of non-metals. Sonority of metal means the ability of metal to produce a ringing sound when we dropped on a hard surface or when we hit on a hard surface. The metals will produce a ringing sound. That property is called sonority. Okay, see, this is a coin. It is made up of metal. So I am going to drop this coin into this tumbler. See, we can hear ringing sound. Is it? Yes. So metals produce a ringing sound when it is dropped on a hard surface. Okay, that property is called sonority. Okay, this property, that is sonority, we will use it for making electric bells. Okay, this bells we can see in temples, church, schools. Is it? So, sonority means the property of metals to produce a ringing sound when it is dropped on a hard surface. This property is called sonority. Okay, example iron, copper, aluminium, etc. Okay, the next is proper sonority of non-metals. Okay, non-metals are not sonorous. Okay, that means when we drop the carbon, the non-metal carbon on a hard surface, we cannot hear ringing sound. That means non-metals are not sonorous. Okay? Okay students, today's class is over. We will see in our next class. Thank you.